The next part of this video series concerns how do we actually open up this sorbent tube so that air can flow through. What we're going to be using to cut this tubing is this ceramic wafer, leaving a mark in a ring around this sorbent tube just past the straight component and before this thin component. What this is going to do is it's going to create a ring of partially cut glass, and what that does when we attempt to break it is will allow the glass to break precisely along this line and leave us a bit of a lip of glass to contain any inner components. So I'm going to skip through the next parts because this can actually take a little bit of time, and the end result that I'm hoping for is to get a nice, somewhat clean ring by cutting back and forth with the ceramic wafer and slowly rotating the tube to develop a scored ring. Before I do, actually, in my right hand I have a nitrile glove, and while this is great for chemicals, one of the most common injuries in a lab is actually glass injuries, and because we will be dealing with glass that we intend to break, there is a very real risk of glass injuries. And like I have in my left hand, on top of the nitrile glove, I'm just using a gardening glove. The reason being that while not as chemically resistant, I have the nitrile gloves underneath, and this is going to provide the tear resistance that we need when working with potentially sharp objects like glass. You can probably see that past the lip of the sorbent tube, there's a bit of a ring, and this is the glass that's been scored using the ceramic wafer. Now hopefully when we go to break this glass, it's going to break around this ring, but no promises just yet. The highly sophisticated tool that I will be using to assist me in breaking this glass is this little GC or LC glass vial. Put this tip of the sorbent tube inside the vial, and by using a levering motion, very slowly mind you, we will hopefully be able to selectively break around the score line. First, I'm going to just try to snap off the very tip by slowly and gently, as you can see, applying a bit of pressure, and we've gotten the start of the break. Now that the tip is broken, it's a lot easier for it to crack and break a bit more, so we can be even more gentle and slowly just apply bits of pressure and try to break it closer and closer to that score line. We've gotten it very close on one side now. Just want to work a bit on the other side. The risk is if you get too greedy, you might break a little bit too much glass. Alright, I'm quite happy with that. Let's just have a look. I'm going to just very quickly try to tap out any bits of broken glass. Doesn't seem like there are any. It's another benefit to having this little vial, it catches the broken glass so you don't leave a mess. Looking near the tip, you can see kind of what we aimed for. We've got an opening that's quite large, but it still allows a lip to contain any large plug. This is ideal. Now I'm going to go ahead and off screen cut the other end of this for the third part of this video series. So as described in the previous video, we have now cut our sampling tube and it is ready for sampling. One key thing to bear in mind here is the direction air flows through the tube. I believe in the first video it was described, but let's just quickly revise. See that little arrow? That little arrow there, you can somewhat see it. It's much more clear on the yellow sorbent tubing, so yep, there it is. The purpose of me showing you that was when you do mount this onto your sampling pump as shown here, you need to mount it in the direction of flow. Before we do that though, let's actually introduce you to this sampling pump. This is the charging cable. If it's charging, you simply remove it. It's magnetic, so no fuss. This is the main screen of the pump. This is the tubing connecting it to the adapter, and this adapter exists to connect your sorbent tube to the rest of the device. So first let's just fit this sorbent tube on. Double checking again the direction of flow. Yep, this is going to fit on here like so. Be gentle. You don't want to force it onto this rubber tubing because you have some freshly cut glass which does have the potential to break even further. So just get it in a few millimeters just until it feels snug, like it's not loose. The suction motion of the pump is going to mean this is not going to come out easily, so it doesn't need to be pushed in too deep. It's going to naturally stay in place quite well. As an additional measure of security, while not necessary, it's good to, as you can see by this thread line, screw on a cover. And this cover has some benefits, like maybe protecting it from light if that's necessary, keeping it out of sight so that people don't wonder why you're carrying some strange glass thing around. It can clip onto your shirt, but it still functions. I'm not sure how visible it is. Oh, there it is. See that little hole at the top of this barrel section? That little hole right there is the air inlet, and actually here it even indicates the direction of flow. It's pretty obvious if you ask me, but there you have it. Alright, so air is going to flow through here, through the tubing to the pump. As for the actual mode of action of the pump, to turn it on, press this button. It's a touchscreen pump. You briefly just saw a flash of what was the previous sample summary. If it doesn't go away, simply press that back button there again. This button isn't too important, that's for calibrations, which we will do for you. This can be important, so when you're designing your experiment, you have a range of possible flow rates from 20 milliliters per minute all the way up to 500 milliliters per minute. For your experiments, it's probably best to just do 500 milliliters per minute. You can click OK like that. Reason being, the faster the flow rate, the more sample you're collecting, the less time you need to wait there. The reason you might sometimes use a lower flow rate is potentially you have sensitive sorbent tubes, and they're only rated up to a certain flow rate. Because above a certain flow rate, they might allow breakthrough, or they might be damaged somehow. You can set the duration you want your scan to run for. You don't even have to do that. You can simply just go straight to pressing play, and then it will just list the duration of your run so far, and you can stop it at any point. As an example, I'm just going to run using this sorbent tube. You'll hear a sound, and this is the pump going into action. Air goes in, air goes out. So in this case, the coconut charcoal would be collecting any BTEX that exists in this lab. You can pretty much just mount this in place wherever you want, put it down, and come back when you think you've been sampling for long enough. Press stop when you're ready to stop, if it's not already on a timer. Pausing allows you to simply pause. It's very intuitive, very easy to use. I don't think you should have any problems, but if you do, please just ask your demonstrator. Having completed sampling, you should now have a sorbent tube with broken ends that ideally contains some amount of analyte inside this sorbent bed, and ideally not inside this breakthrough bed component. To actually extract this now from the sorbent bed, what we're going to have to do is break it open. To do this, we have a glass cutting tube. It has a tungsten blade, or tungsten carbide blade, sorry. The reason we haven't used it for the ends is simply because it's not a good fit. However, for the middle, again, this is a tubing cutter. It's much simpler to use than the ceramic wafer. I'm going to aim to cut it here, and we're just going to go in a motion like this. Let's give it a go now. So I'm holding it, thumbs are together, these two fingers are a bit further apart, and we're going to kind of lever it like so. And what this ideally should do is cause it to snap in a way that the tube opens upwards. And I'm going to do this in one quick motion. Lovely. The next step is to get that yellow stuff, or that sorbent material, inside this. What I'm going to do is I want to carefully pull out this wool in a way that this upright sorbent tube doesn't spill all the material, or the packing material, out. So do this part really carefully, because otherwise you'll be upset with yourself having wasted a lot of time. I'm just trying to tease the wool out, as you can see. Now I've finally gotten a good grip. As you can see, there's now the free sorbent material. I'm going to get a glass vial and very simply, waiting for that to come in focus, tip it in. Alrighty. If there's a tiny bit of sorbent material left over, as there clearly is here, it's not a huge issue because you get to a point of diminishing returns in trying to get rid of all this material. You can very gently try flick it out, but if with a bit of effort it doesn't come out, just leave it. It's really not that important, and you're much more likely to either drop all your sorbent material, as has happened to me before, or potentially cut yourself. So yeah, just leave it. Now that we have our main body of sorbent material, what we will be doing is extracting this body. Depending on your experiment, you might need maybe 0.5 milliliter up to 5 milliliters. Of course, note how much you're going to be using in your actual experiment. In this case, there should be somewhere between 0.5 to 2 milliliters. I'm going to cap the top. And methods may vary, but they will tend to say leave this to rest with occasional agitation for somewhere between half an hour to 1 hour. And so as far as occasional agitation, just give it a light flick, very gently. You don't want all this sorbent material to kind of get shocked upwards and stick to the glass and then not actually extract from the solution. But this should actually be a fairly efficient extraction, so having given it a light shake, put it down and wait. You probably have other tasks to do in the meantime, so you can get to that while this is extracting. As for the second sorbent bed, you should, in addition to extracting the first bed, use your cutter and make another mark over here, and using that cutter, break this, take this second breakthrough bed out and extract that. The reason you want to do that is if you're detecting any of your compound in this breakthrough bed, that means you've saturated your first bed and you've essentially sampled too much.